All right, so let's get into what we're going to do today. And that's talking about, like I said, distance, midpoint, slope. Okay. So here we go. I'm going to get a sheet of paper here. I think most of this is review. I feel like you've, I know at least everyone's on slope, for sure, right? I think distance, though, to a certain extent, maybe, and then also midpoint, too, I would think. But slope, for sure, I know that's review. Okay. So, we're going to go in this order: slope, we'll look at the midpoint, and then also distance as well. Oh, so there you go. Okay, home ready for me? Okay. Here's your stapler, and usually I put that on my clipboard. You got it all organized. Or not clipboard, sorry. Put it on my keyboard up here. That'll be fine. All right. First thing, though, and I know this might seem a little basic, but I want to go over what the coordinate plane is to a certain extent, okay? And kind of talk about that just a little bit. Because now that we're in geometry, we kind of have a different way to approach it, right? This is coordinate plane. You've been using this forever. Maybe you don't think about it very much. You're just like, I know, you find points, you can draw lines on it, graph things, you know, who cares? But let's think about what it really is. Remember, the coordinate plane is made of two number lines, okay, at right angles to each other. Okay? And if two lines intersect and form a right angle, what do we call those two lines? They are what? If they intersect at a right angle, we call them... Yeah. No, not angle. No, not. I mean, technically, yes, they do bisect each other, but if they meet at a right angle, it starts with a P. Parallel is if they are perpendicular, though, is the word. Exactly right there, Joey. Yes. So perpendicular, right? They're perpendicular to each other. Okay. And so by putting those two lines at that right angle, this creates a plane. Okay. Yes, like a geometric two-dimensional plane. Okay. And then any point in that plane, right? A plane is filled up of an infinite number of points. Any point can be identified / located by using one number from each line. Okay. Remember that idea about assigning numbers and coordinates to lines, right? That's from the ruler postulate. And so now we're essentially taking two rulers and putting them at a right angle to each other and getting a coordinate from one ruler and then a coordinate from another ruler, and then that locates any point in a plane. Okay, the coordinate plane. Coordinate. Okay. And that locates a point. All right, so we're really, the coordinate plane is, you know, geometry, right? You were doing geometry in algebra and stuff like that, anytime you were graphing. So first thing we'll look at is slope. We'll get more into lines a little bit later, but not right now. Right now we'll just talk about some concepts. So like slope, for example. The slope, okay, we can think of that as like the rate of change of a line. Or you can also say function as well. In calculus, you'll figure out how to get the rate of change of a function. Okay. The slope, right, is referred to as the variable m, right? Sometimes in math, a concept or an idea is so important, we give it a typical variable. So slope is always m for whatever reason there, okay? Which is then rise over run. That's one of the basic concepts that we have about slope, right? How much your line goes up or down by, over how much your line goes left or right by. And so that formula, y2 minus y1 over x2 minus x1. Okay, and this is known as the slope between, and I guess I'll say x1 comma y1 and x2 comma y2, those 2 points. This formula you will need to have memorized, okay? And memorized more than just being able to regurgitate it, but to apply it appropriately, right? I find that when I teach slope and midpoint and distance together, students oftentimes get these ideas confused, right? I might ask you to find the distance between 2 points, and you end up giving the slope between the 2 points, okay? Because both result in a single number as the answer, but of course they mean different things, right? So I'm going to asterisk this. You need to know that one for your test and for all future, assessments and stuff. We need to have that down, okay? One other way you might see this. This is a Greek letter, not a triangle. Okay, anyone know what that Greek letter is? Delta, that's right. Have you seen it in any classes before? Algebra-based physics? Algebra-based physics? Yeah, ABP, okay. So, right. Delta, what does that delta normally represent? Change, exactly right. So sometimes you'll see this rise and run, or the y2 minus y1 over x minus x1, you'll see that as delta y over delta x. Your change in y, the difference in the y's, over the change in x, the difference in the x. Exactly right. Cool. I didn't have anyone in my second block class that was, they knew the letter, but they didn't know that it was meant to change. So good job, guys. Change in y, change in x. Okay. And of course, we have different kinds of slope. Right? We've got positive slopes. Okay. If a line has a positive slope, what is that line going to do? Increase as you go from which direction? Left to right. Yeah, very important. We want to be careful because we could also talk about increasing from right to left. That would actually be then a decreasing thing, right? But anyway, yes, the line increases from left to right. I'm just going to use L to R like that. Okay. All right. Then, of course, we can have negative slope. All right. And so there, of course, the line will decrease left to right. I don't know what that squeaking is. I'll go close the door here. All right. A zero slope. We have positive, we have negative. Zero slope is also possible. What does a zero slope look like? A positive is increasing, a negative is decreasing. What else is left for there to be? Yeah, go ahead. It's a straight line, okay. But all lines are straight lines, right? So what do you mean by that? From left to right. Horizontal, right? Horizontal would be another way to put it. Yep. Mm-hmm. So, or another way to describe it, if it's not increasing and it's not decreasing, you could say the line is constant. Okay. If something's not increasing, not decreasing, you could say it's staying constant then. Okay, or if you want, you can say or flat. Or horizontal would be even better. Yeah, good way too. So from left to right. And there's one more option, and that's undefined. So a slope can be positive, a slope can be negative, a slope can be zero, or a slope can be undefined. What does an undefined slope look like? Yeah. Vertical line, right? The line is vertical. The line is vertical. Okay. Oops, I'm off the screen. Sorry about that. There we go. Okay. The line is vertical. Which, undefined as a value, that means you're dividing something by zero, right? Undefined, when you see something being divided by zero, that is undefined. Okay? So like, 2 divided by 0, that's undefined. Okay? And it actually kind of makes sense that a vertical line would have an undefined slope. I mean, if you think about, okay, let's say I draw a quick little coordinate plane here, a little sketch, and I'll draw like a vertical line on that coordinate plane. Okay? Draw a vertical line on that coordinate plane. What if I pick any 2 points on that vertical line right there, so pick any 2 points on that vertical line right there, which coordinate is not going to change? Which coordinate will stay the same for any point that's on that vertical line? The x-coordinate will stay the same, right? Because this line does not move left or right at all. So every coordinate along here is going to have the same x-coordinate. Different y-coordinates, but the same x-coordinate. Now, if we go to our slope formula here, if the y-coordinates are different, we'll subtract them and we'll get some number up top, right? But if the x-coordinates are the same and you subtract them, what number are you going to get on the bottom? 0, right? So you have a number over 0 that's undefined. So you get that slope. Same argument can be made for the zeros, right? A horizontal line, the y-coordinates stay the same because you're not going up or down. If the y-coordinates are the same, you'll have the y-coordinate minus itself. It'll be 0 on the top over a number on the bottom. When you have 0 in the numerator of a fraction, the overall value of it goes to 0. And so then okay. So let's do 2 here real quick. Let's see. Actually, you know what? I'm going to have you guys try these 2. I don't even think I need to do an example. I think you guys can do slope pretty easy. So you guys try these. Find the slope. Okay, of given, I'll give you 2 scenarios here. Okay, so go ahead, take like a minute. Take a minute and get those slopes calculated for me real quick. Watch your order there. I think you did your X on top and your Y on the bottom instead of Y on the top. Check. Did you do it on your calculator or do it in your head? Okay, so yeah, check it out. Let's see here. You might have covered it. I think you will. So, yes. Okay. Yeah. So you it's the y coordinates. So you did these 2. This y minus y. X minus x. So you can add y on top. You might have the same thing. Looking good though. Good job. Okay, let's take a look here real quick. Okay, should have gotten 5/3. 8 over -5. Okay. Questions on any of that? We're all good? I guess so. What does the time say? then yes, you should go now. Okay. No questions on that? Ready to move on?
Wait, I don't understand.
Which one? Both of them?
No, the first
one. First one. Okay. So did you have a similar setup here?
No. Why did 6 minus 0 and then 3 minus 1? I don't know.
Okay. So do you see what your error was?
Well, I must have gotten them mixed up.
Right. So the 6 is your y coordinate, and then you want to subtract 1, the other y coordinate. So 6 minus 1. And then 3 minus 0.
I wrote it wrong.
Oh, okay. Then that'll do it too. Yep. Okay. Other questions on that? All good? All right. So obviously positive slope here. This line would be increasing. Negative slope here. This line would be decreasing. Stuff like that. Okay. Moving on. Let's go to midpoint here. So and I'm just going to give you this. The coordinates for the midpoint. Okay, the coordinates for the midpoint. We already know it's going to be halfway between. We've got to figure out where it is. All right? It's the same idea that we just used back for the warm-up. Okay? The midpoint. The first thing we want to do is find the midpoint of the x-coordinates. So we're just going to take the x-coordinates of our 2 points, because again, in order to find the midpoint, you need 2 points and find the midpoint between them, right? So you're going to add up the 2 x-coordinates and divide those by 2. Find the average of the x-coordinates. And then, for the y-coordinate of your midpoint, you will add the y-coordinates of the 2 endpoints. Okay? So in a midpoint, its answer, the solution, a midpoint is a point. It needs 2 coordinates. You need an x-coordinate, you need a y-coordinate. That's why there's a comma here. We're like finding the point. Okay? To find the x-coordinate of the midpoint, you add up the x-coordinates of the 2 endpoints, the point where you want to like find the midpoint between, right? Find the midpoint. Add up the x-coordinates, divide by 2, add up the y-coordinates of the 2 points, divide by 2. So let me give you an example here, right? Okay, so let's say we want to find the coordinates of the midpoint of segment GH given G is at coordinates -2, -3, and H is at coordinates 2, -1. Okay. Now we're thinking 2-dimensionally, right? On the warm-up, we were thinking 1-dimensionally. What's the midpoint between this number and this number? Now we're thinking 2-dimensionally. Okay. We want to find that midpoint. And so here's what we do, right? We just take our 2 x-coordinates, -2 and 2, add them up, and divide that by 2. Find the average of those 2 x-coordinates. And then the y-coordinates, add them up, and divide by 2, finding the average of the 2 y-coordinates. Okay? Those will be the coordinates for the midpoints once we simplify here. So -2 plus 2, 0, divided by 2 is 0. -3 plus -1, -4, divided by 2, -2. And there it is. There's the coordinate for the midpoint. Okay, there's the coordinate. If you want to, right, you can like type this in your calculator here. I'll show you real quick. You can like type, you can help yourself do the math. So, I can type in like -2. Let me see here. -2 plus 2 divided by 2. And I get -1, which is, I got 0 there. -2 plus 2 over 2. And I said it was 0, but here the calculator is saying -1. So, yeah. I need parentheses. That's right. Okay, don't make this mistake I just made there, folks. You got to group the numerator and group the denominator, right? A fraction bar, believe it or not, bless you.
Bless you.
Goodness. A fraction bar is a grouping symbol. Okay, it groups the numerator, it groups the denominator. So you need to put parentheses on the numerator and parentheses on the denominator. Now when I group them together like I'm supposed to, we get that 0, like we should. Okay? So make sure you do that. Don't make this mistake on your calculators, all right? You're going to do all the hard work of setting it up and like getting it right, and then you're typing your calculator incorrectly. All right? So be careful with that. Okay? Questions on midpoint. Find the midpoint between 2 points. Okay? Again, you'll need to know this one too. Won't be giving it to you. Won't be giving it to you. So you'll need to know this and when to use it. Okay? Know it and know when to use it. All right. Last bit. Last bit. Almost done. And you guys can start on your assignment here. All right. Distance formula. And I saved the best for last. Okay. Best one. Longest one. Distance formula. Okay. So, before I give you the actual formula here, let's think about this a little bit. All right. So before we do the actual distance formula, right, there are some situations where we can figure it out without having to do any sort of like crazy calculations or anything like that. All right. For example, an easy problem is what is the distance from A that has coordinates 0, 3 to B that has coordinates 0, 9? Read. 6. Exactly right. Did you use a distance formula there, Reed? No. Don't need to, right? Oops, I'm off the screen. Ooh, there we go. How'd you know it was 6? 9 minus 3 equals 6. Very good. Very good. Okay? That's right. The x-coordinate for A and the x-coordinate for B are both 0. That means these points are above each other, right? If I were to sketch this, maybe I'll just sketch it here real quick because I'm feeling extra artistic today, maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0, 9, and 0, 1, 2, 3. Okay, there's A, there's B. And yes, this distance here is a distance of 6. Okay, that's it. They're the same distance. Or not same distance, same x-coordinate, so it's just the actual vertical distance. How about another one? How about, what about the distance from, whoops, not B, from A, which is at 0, 3, to a point C, which is at coordinates 6, 3. So I actually draw this one here. So let's see here. 1, 2, 3, 4, 5, 6, and then 1, 2, 3 right there. There would be C. What's that distance? 6. That's right. I wasn't very original there. I should have maybe changed the numbers up. But 6, yes. Because again, A and C, right, they're not above or below each other. They're just directly left or right. So we can just count. 1, 2, 3, 4, 5, 6 across. Okay, 6. Another easy one. But now, what's the distance, from B to C? What's the distance from B to C? Why is this a harder question? Yeah, read. Yes, we're moving not only vertically to get from B down to C, right? We're not only moving vertically, we have to go down, we also have to go across too. So we can't just count these little units, right? Our coordinate plane is oriented, vertically and horizontally. We don't have like diagonal, we don't have like a diagonal axis. So we got to come up with a distance. with the way we have things set up, with the previous work that we've done, what can we do? Yeah, the thing from the warm-up, right? Pythagorean theorem. Exactly right. Okay? Because we have a right triangle here. In this case, we have a right triangle between these two things, and so we can find this distance here. Okay? And so it's going to be then, yes, 6 squared plus 6 squared equals, and we'll call that c squared. So it's 36 plus 36, which is c squared, so we get 72. And so c is the square root of 72. Okay. Square root of 72. Good. Okay, I gotcha. If you look here, right, we want to find this length, right? This length is a hypotenuse of this right triangle that we have right here, right? We have a vertical leg and a horizontal leg. Okay. Now, how did we do that, right? We wanted to find this distance. We knew this length and this length, right? This length, what did we do to get that? We subtracted the x coordinates. What did we do to get this length? We subtracted the y coordinates. So, in like a summarization, we took the difference in the, let's do the difference in the y coordinates there first. And we're going to square them as part of the Pythagorean theorem. We then took the difference in the x coordinates and squared them, again, as part of the Pythagorean theorem. And we set that equal to this distance that we were trying to find right here. We called that c squared, but in general, it was just the distance. Okay. Instead of squaring d, like instead of saying d squared equals a squared plus the b squared there, we put a square root here over the entire thing, and voila, we have the distance formula. There it is. Okay. The distance formula is just a manipulation of the Pythagorean theorem. That's all it is. Change in y between the 2 points, the change in the y between these 2 points, the change in the x between these 2 points. Again, it's this change in x. Okay. Square each for the Pythagorean theorem, add them together, and then square root that quantity. Boom. There's your answer. And again, this formula you will need to know. Okay, you'll need to know that one. Oh, show. All right, so let me give you one to try. So, if you would please, find the length of LM given L has coordinates 5, -4, and M has coordinates -4, 1. Okay, and I'll leave the distance formula up there for you to see. Okay. So go ahead, use that distance formula. Find your L, find your M. And I'll kind of come around and help you. If you finish this and you're like waiting for me to come around and check it for you or something like that, you can feel free to go then to your Google our Google Classroom, and check out our homework. It's on. It should be posted. It's just a worksheet, so you can get started on that. Okay. So once you get this done, you're feeling good, or I haven't come around, yet to check yours. You can feel free to go ahead and get started on that from the Google Classroom, and then I'll come take a look at it in just a second. Any questions or something like that too? If you're not sure, looking good. So far, so good. Don't get the square root symbol over the whole sum. Just tracking. Okay, so far, okay, so starting out good. Start plugging some numbers in. Okay, gotcha. Second straight here. Or you're still figuring out like what to do and stuff like that. Yeah. Yes, good job. So when so it's 1 minus negative 4. Right? It's 1 and then minus negative 4. So minus negative 4 plus positive 4 times negative 5. And then negative 4. And then 4 and that's negative 4 minus 5. And negative 9 squared is positive 81. You got to put parentheses around it. So what are we using to calculate? If you don't put parentheses on the negative 9 squared, it's probably going to be wrong answer. If you care, I'll tell you why it does that, but if you just want to just fix it,
I don't know how to do this.
so, well, I would go, I mean, if that's not an emergency, I suggest you make a start by writing this formula down. And seeing what, yeah, right there, yeah. Okay. And then start by good, yes. If you can just solve it, that's fine. That's fine. Yes. But I mean, I'm not going to, so, like, here's what I'm going to expect you to do. I'm going to ask you to do stuff like this. If you can do that, using your method, okay with that. Is there another way to measure it? So, because obviously, like, I mean, there is, you can, I mean, but the problem is you need, with the square root of 106, since it is irrational, right, that means it goes around the decimal before it goes on forever, it doesn't repeat regularly. So you can, like, eyeball it, you know what I mean? Like imagine trying to measure this with a ruler, right? So the way we do it is we take one of these number lines, and then put like the 0 of your number line right here, and this would go out to the square root of 106 is like 10 point something. So at this point we go, we put the 0 of this number line, and put it down to the 0 number line here, and go out to essentially, yes, yeah, basically, that's a good way to kind of eyeball it, yeah. So first of all, let's pause right here because actually this is 1 minus a negative 5 plus positive 4, right? That would be 5. You draw it right. That's absolutely fine. You're doing the same work essentially, so that's fine. Now, are you going to be able to do that if the numbers are big numbers? Okay. Okay. All right.
I mean, I don't know.
Yeah, that's the only thing. If the numbers get bigger, I'm just. I sent the so send it. Okay, comes right. So it should be coming. I should have it for you by tomorrow. Okay. Yeah, I don't have. I was wondering how that would. I'm sorry. Yes. Good job. Yes. Well done. All right. So again, on the homework, folks, you got it. You can check it. Yes. Good job. Yes. You're feeling good about what we want the homework there. It's the worksheet there. Great. Well done. Yes. So what's happening is that it will be better on the test. first quiz. I would like you to, but you didn't read it like that, and I wouldn't count it wrong. So, but I would like you to. But I wouldn't count it wrong. Okay. Please note, folks, for the Google Classroom thing that you don't need to graph anything. Okay, even if it says to graph, you don't need to. Okay. And then there's one other thing. Oh yes, like 4 and 5, I think. No, sorry, 5 and 6. We haven't talked about one like that, but I'd like to give it a try and see if you can figure it out. Okay, so 5 and 6, we haven't talked about ones like that, but I wanted you to give it a try and see if you can figure it out. Are you allowed to use what? Sorry, what? You're asking me a question? No. Say again? It's already on the Google Classroom, so yes, go ahead and pull that up and get started on it there, if you don't mind, please. So that way we can get you any questions you might have answered.